Request scope providers can sometimes lead to increased latency since we're having at least one request scope provider injected into, let's say, a controller instance, or deeper, injected into one of its providers, makes the controller request scoped as well. That means it must be recreated or instantiated for each individual request and garbage collected afterwards. For instance, for 30,000 requests in parallel, there will be 30,000 ephemeral instances of the controller and its request scope providers. Having a common provider that most providers depend on, for example, a database connection, automatically converts all those providers to request scope providers as well. This can pose a challenge in multi-tenant applications, for example, especially for those that have a central request scope data source provider that grabs headers, tokens from the request object, and based on those values, retrieves the corresponding database connection schema specific to that tenant. For instance, let's say you have an application alternately used by 10 different customers. Each customer can have its own dedicated data source, and you want to make sure customer A will never be able to reach customer B's database. One way to achieve this could be to declare a request scope data source provider that, based on the request object, determines who the current customer is and retrieves its corresponding database. But, as we said, a major downside to this approach is that since most likely a large chunk of your application's components rely on the data source provider, they will implicitly become request scoped as well, and therefore you will undoubtedly see an impact in your app's performance. But what if we had a better solution? Let's say that we only have 10 customers. Couldn't we have 10 individual DI subtrees per customer, instead of recreating each tree per request? Well, if your providers don't rely on any property that's truly unique for each consecutive request, for example, request UUIDs, but instead there are some specific attributes that let us aggregate them, then we have no reason to recreate the DI subtree on every incoming request. This is exactly where durable providers come in handy. In the next 2 lessons, we'll show you how to leverage durable provider features when implementing 2 common use cases: internationalization and multi-tenancy.